Hello everybody, welcome to Prestressed Concrete Structures by Anglish Sharati. Contents: Introduction, how to make prestressed concrete, advantages, difference between RCC and PSC in construction industry. Introduction, a brief history. Eugene Freisnet 1879 to 1962 is termed as the father of prestressed concrete. He detailed search on prestressed concrete structures. Fresnet used prestressed concrete techniques to restore the threatened foundations of Lee Harvey Marine Terminal. This was the beginning. Application of prestressed concrete in civil engineering. Prestressed concrete is used today for large building works in many civil engineering fields such as roads, buildings, bridges, water, energy, public facilities, etc. Le Grande Arch in Paris was constructed using massive 70-meter span post-tensioned I-beams to carry the upper deck of the three floors. Significance of prestress. Prestressing applies an initial compressive axial force to the concrete, which greatly reduces or eliminates the internal stresses. It does this applying a tensile stress to the steel cable running through this concrete. The steel cable is then anchored and the compressive force is then transferred to the concrete by bending forces. A pre-stressed concrete member is one in which there have been introduced internal stresses of such a magnitude and also distribution that the stresses resulting from external loadings are contracted to a desired degree. So this is the basic thing. The load is applied. These are the anchorages, and this is the high strength steel cable which is pre-stressed. The benefits of pre-stressing are cracking is greatly reduced or eliminated, and applying the pre-stressing force below the neutral axis induces the moments which oppose those caused by the externally applied loads, thus significantly reducing the deflection. Member sections are smaller than reinforced concrete sections for same imposed loads. Pre-tensioning. Tendons either pass through a single mold or line of molds for multiple members arranged end to end and can be attached at one end to fixed anchorage. The tendons are then tensioned between the fixed anchorage between an externally independent anchorage to give the required tensile force in the tendon. The tendons are then held in place while the concrete is poured. When the concrete has hardened sufficiently, the ends of the tendons are slowly released from the anchorages. The tendons are restrained from gaining their original length by development of bond stresses between the concrete and the tendon, and it is these bond stresses that transfer the compressive stress to the concrete. So that once the tendons are cut off, you can see that uh, the how the stresses are redistributed. Post tensioning. Post tensioning is another method of applying stress to the concrete member. Thus, the tendon is placed in the correct position in the formwork with dead end anchorage and live end anchorage through which the tendon passes. The concrete is then poured and left to harden. When concrete has gained sufficient strength, a jack is attached to the live end anchorage and the uh, tendon stresses to be required force. The operation is the tendon is stressed to the required force. The operation is to be carefully done as any error could impair the structural integrity of the member. The tension force in the tendon is transferred to the concrete as a compressive force by reactions at the anchorages. The jack is then removed. These are the dead end anchorages. To prevent the tension from slipping back, it is locked into the anchorage by the means of a split wedge located in the barrel of recessed anchorage. Tendons used for pre-stressing generally consists of several high-strength wires of small diameter wrapped around a similar wire. This is called a pre-stressing strand bar tendons made of high-strength steel. It will soon be embedded in the concrete. Based on how tendons are used, they can be classified as bonded tendons, unbonded tendons. Bonded tendons can be used. The process is essentially the same except that the pre-stressing force is transferred to the concrete both by reactions at the anchorages and by the bond stresses between the concrete and the bonded tendon. Whereas unbonded tendons are usually normally assembled under factory conditions, they consist of strands or wires that are wrapped or encased in public plastic having been first coated with a grease or bituminous material. In the floor construction, bonded tendons are provided in the beams and unbonded tendons in the ribs of troughs of the slab. This photograph shows the tendon layout of the post-tensioned flat slab. The tendons are placed in position before the concrete is poured. When the concrete has gained sufficient strength, the tendons are jacked to predetermined pre-stressed force. Bonded tendons. We can see that these are the bonded tendons. When concrete has gained sufficient strength, the tendon is stressed, and when the sleeve is filled with grout under pressure through tubes placed at intervals along the sleeve. The grout bonds the tendons to the sleeve, thus enabling the transfer of stress from the tendons to the concrete. How pre-stressed concrete is made? It begins at a pre-stressed concrete plant. The pre-stressing strand is stretched across the casting bed. Anchorages embedded in the concrete member are generally required only for the post tensioning. The post tensioning members are manufactured and are anchored by bond stresses rather than anchorages. One anchorage simply holds the end of the tendon in position, while the other is used with a jack to stress the tendon. Each anchorage is attached to the end of the tendon before the concrete is poured. The type of anchorage used depends on the number of tendons and whether they are strands or wires. The pre-stressing jack is attached to the outside plate of the anchorage through which the ends of the tendon project. Once the jack has been connected to the tendons, stressing can begin. The predetermined stressing force can be applied to each tendon individually. The force is applied according to the design engineer's specifications. Special trucks bring concrete to the casting bed where the pouring begins. Once the pouring is complete, a tarp is placed over the form and is applied to the cure the concrete. The pre-stressing strands are cut and the concrete form is removed from the casting bed. The ends are cleaned and pre-stressing strands are sealed with a protective coating. The end product is shipped to the building site. The pre-stress force in bonded tendon is transferred to the concrete by bond stresses. There are two stages at which bond stresses are considered in the design of pre-stressed concrete elements. At transfer, the tendons of predetermined element are released and the pre-stress force is transferred to the concrete by bond stresses. Flexural bond stresses develop when members are subjected to external loading. However, such stresses are likely to be negligible until the member has developed flexural cracks. Advantages: improved resistance to shearing forces, reduce the shear forces developed at the support sections stiffer. Indirect long-term savings is more. economy for long span structures. Tensile strength comparisons between RCC and PSC. Tensile strength, improved stiffness, shear strength, cracking and deflection ability, serviceability, economy and safety. Pre-stressed concrete in construction industry. It is well established fact that basic economy of pre-stressed concrete lies in the high strength to weight and strength to cost ratios, its resistance to fire and corrosion, and its versatility and adaptability.